Well, I'd now like to work through some special cases of expanding brackets, and we've already seen how to use FOIL to expand brackets. So FOIL, first, outer, inner, last. What happens when we've got three sets of brackets which we've got to expand? Well, we've also seen that in the distributive law that, in the associative law, that it doesn't matter which order you do multiplication. So we could choose to multiply the first two together and do that as a separate step and then multiply by the third. Or we could do, which is what I'm going to do here, multiply the last two and just keep this one and we'll multiply by it at the end. So 3h minus 2, we'll just leave it there for the time being. We'll now use FOIL. So we've got first, h times 1 is h. We'll just put two brackets together there, indicating that there's a multiplication in between. So we've got h times 1, that's first, outer. H times negative 2h is negative 2h squared. Inner, plus 4 times plus 1 is plus 4. And then the last is plus 4 times negative 2h is negative 8h. Always try and collect like terms as you go, and here we can have a look and see, well, we've got some h's. There's only one term with h squared, there's only one constant term, but we've got a plus h and a minus 8h, so we could collect those before we do this multiplication. So that'll be equal to 3h minus 2. Once again, we could go in ascending or descending order, doesn't really matter. I'm going to go in ascending, so I can start with a positive 4 rather than a negative 2h squared. So I'll go 4. I like to put a line through these as I collect them, so I've got the plus 4 taken care of. H minus 8h is, that's plus 1h minus 8h is the same as taking 7h. So we've got those taken care of, and then minus 2h squared. Next step is to use the distributive law to expand these two brackets. There is no FOIL for doing brackets when we've got three terms inside, so it's just a matter of going right back to the distributive law. The 3h will be distributed over every term in the second, so that will be 3h times 4 minus 3h, now that minus came down here, 3h times 7h. Minus 3h times 2h squared. Okay, so that's just the 3h times each of those. Now we've got a negative 2 times each of these. Negative 2 times positive 4 is negative 2 times 4. Negative 2 times a negative 7h is positive 2 times 7h. Negative 2 times negative, that will be negative times negative is positive 2 times 2h squared. Okay, that will be 4 3s are 12h minus, multiply the coefficients first, 21h squared minus 6h cubed. So 3 times 2 is 6, h to the 1 times h to the 2 is h cubed, minus 8 plus 14h, and then plus 4h squared. Collect like terms. Doesn't really matter whether I go ascending or descending. If I start with a constant term, I'm going to start with a negative 8. If I start with a h cubed, so I'm going to start with a negative, so it really doesn't matter. Let's go descending powers. Negative 6h cubed, we'll start with the highest power. Then get the h squareds together. So we've got plus 4h minus 21h, so plus 4h squared minus 21h squared. If we add 4 and then take 21, that's the same as taking 17h squared. a line through those two. Then the h's, so we've got plus 14 plus another 12h, so that's plus 26h. And then our last term is negative 8. Alright, so when we expand this out, we get negative 6h cubed minus 17h squared plus 26h minus 8. Just go through it step by step. You could experiment if you like and do these two brackets first and leave this at the end, so you'd have a big bracket and then you'd have 1 minus 2h at the end, and then multiply each term by 1 and each term by negative 2h. Collect your like terms and hopefully you'll get the same answer. Another two that are worthwhile remembering are perfect squares, so a minus b and a plus b squared. Now you could use FOIL, you could write it a plus b, and then use FOIL, but probably it's worthwhile remembering how to get straight to the end result. Get straight to the end result, you square the first term, leave a gap, then we square the last term, and then it's twice the product of the two. Now the two terms multiplied together are just AB, and then twice that is 2AB. So that sort of takes away the intermediate step of using FOIL. Go straight to the answer. Same method here, square the first term, we get A squared. Square the last term. Now the last term is negative b. Negative b squared is positive b squared. The product of the two is a times negative b is negative ab. Twice that is negative 2ab. So once again, I suggest that it is worthwhile committing that to memory. Also note that a plus b all squared, and I see this quite often, is not equal to a squared plus b squared. A lot of people like to take a shortcut and just square the first one, square the last one. We've seen that's not the case. That's only 2/3 of the answer. You're still missing that middle term. So don't ever think that a plus b all squared is equal to a squared plus b squared. Let's do an example. So we've got 2 square root of 3 plus square root of 5 all squared. Look at our pattern. We square the first term. Now we may need to make an intermediate step here. Square the first term, leave a gap for the middle term, and then we square the last term. And then it's twice the product of the two terms. The product of the two terms is 2 root 3 root 5. That's the product of the two terms. And then it's twice that. So we can put that. And it is going to be plus because you've got a positive times a positive there. If that was a negative, it would be exactly the same except there'd be a negative there. If you go and look at the pattern up there, it's first terms are the same. It's just the sign of the second term that changes according to what the sign is there. All right, when we expand that, we've got 2 times root 3 times 2 times root 3. So that's 2 times 2 is 4, and root 3 times root 3 is equal to 3. So that's 4 times 3 plus 2 times 2 is 4. Root 3 times root 5 is root 15. And then plus root 5 times root 5 is equal to 5. 4 3s are 12. And 12 plus 15 is 17 plus 4 root 15. Okay, so that's just using the shorthand way of the rule there for expanding out. Just be careful if that's a negative. You'd have to put a negative there, and actually that would be a negative as well.